Previously, what we learned are the column vectors, which tell us how far they go in the x and y direction, like going right 3 steps and outwards 4 steps. Now let's move on to a different kind of column vector. It's called a position vector. A position vector looks like a column vector, but there's a big difference in the meaning. While a regular column vector tells you the movement or displacement, a position vector actually tells you where the point is relative to the origin, which is 0, 0 on the graph. So for example, if we say the point P is 3, 4, then the position vector from the origin to point P is where x equal to 3 and y equal to 4. This means that you start from the origin, move 3 units across to the right, and 4 units up. A column vector tells you how far in which direction to move. A position vector tells you the actual location of a point starting from the origin. Both are written in the same form. That's why it's important for us to understand the context. Let's go through this diagram together to understand how to find the vectors between 2 points using the triangle law of vectors addition. We are given two position vectors. You can see point A is at where x equal to 2, y equal to 1. And point B is at where x equal to 5 and y equal to 4. The position vector OA means the vector from origin where x equal to 0, y equal to 0 to point A. This gives us OA, vector OA equal to 2 over 1. Similarly, the position vector OB is the vector from the origin to point B. So vector OB equal to 5 over 4. Now, we want to find the vector from A to B written as AB. According to the triangle law of vector addition, if you go from A to O and then O to B, you will get vector AB. So we have vector AB equal to vector AO plus vector OB. We do not have AO, but we have OA, so we can flip the direction to have negative OA instead of using vector AO. And then now we can replace the equation with vector OB minus vector OA, where we have vector 5 over 4 minus vector 2 over 1 to give us vector 3 over 3. That means to move from position A to B, we need to move the vector 3 steps to the right and 3 steps up.